Section 9.1 Part 3, Estimating a Population Proportion. Lesson objectives: construct a confidence interval for a population proportion. Interpret a confidence interval for a population proportion. We'll begin with an example. If you recall, this is the same example from the previous video where a university poll asked how many people were in favor of the death penalty. 1,123 were in favor out of 1,783. We want to obtain a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. Solution: p hat is 0.63 as we computed in the previous video. We need to check the requirements. N times p hat times 1 minus p hat is equal to 1783 times 0.63 times 1 minus 0.63, which gives us 415.6, which is larger than 10. And we also know that the sample size is less than 5% of the population size. Our population is all adults living in the U.S. Our sample size was only 1783. Alpha is 0.10 as we are doing a 90% confidence interval. So Z alpha divided by 2 is Z.05, and we can see from table 5 that this is 1.645. So our lower bound is our point estimate minus our Z alpha over 2 times our standard error. And our standard error is the square root of p hat times 1 minus p hat divided by n. This computes to be 0.61. Our upper bound is simply the point estimate plus the margin of error, which is our critical value of Z times the standard error, which gives us 0.65. So our 90% confidence interval is 0.61 to 0.65. Lesson objective: interpretation of the confidence interval. A 1 minus alpha times 100% confidence interval indicates that if we obtain many simple random samples of size n from a population whose proportion p is unknown, then approximately 1 minus alpha times 100% of the intervals will contain p. Now, what does that really mean? Well, it means if we were to construct a 99% confidence interval with a lower bound of 0.48 and an upper bound of 0.61, we would interpret the interval as this. We are 99% confident that the true population proportion is between 0.48 and 0.61. So, for example, a 95% confidence interval, alpha equal 0.05, implies that if we did 100 different confidence intervals, each one based upon a different sample from the same population, we would expect 95 of the intervals to contain the parameter and 5 not. This is our interpretation template. What's in red changes, what's in black stays the same for each interpretation for a confidence interval. So we say we are, then we state the level of confidence. It's either going to be a 90, 95, or 99%. Then we say confident that the true population proportion. Very important that we say population proportion or true population proportion is because we are using p hat to estimate a larger population proportion. We always want it in terms of the problem. We say it is between or is in the interval. We state the lower limit and then the upper limit. And we could also say that we state the level of confidence, confident that the true population percentage, give that in terms of the problem, is between, we state the lower limit, percent sign, and the upper limit, percent sign. Okay, let's look at some misconceptions about the interpretation. Now the value of P is a fixed number. It is either in the confidence interval or not. So it would be incorrect to say there is a 90% probability that the true population proportion is in an interval. What is correct to think about is if a large number of samples is collected and a confidence interval is created for each sample, then approximately 90% of these intervals will contain P. We're just not sure if our confidence interval contains P or not. A 95% confidence interval does not mean that there is a 95% probability that the population proportion lies in the interval. The population proportion is fixed, so there is no probability associated with it. The probability has to do with the interval from the sample. This is because different samples will give different sample proportions, and this is known as sampling error. So we can say that there is a 95% probability that this interval contains the population mean, or we can say that if this process was repeated a large number of times, 95% of such intervals would contain the population proportion. Just remember, the probability is associated with the interval, which is based upon a sample, not the population proportion. The horizontal segments represent 90% confidence intervals for different samples of the same size. In the long run, 9 of every 10 such intervals will contain P. So that's why we call it a 90% confidence interval. So if we pick out an individual confidence interval, like this one, either it contains P or it does not. In this case, this one contains P. If we were to get a sample and produce this confidence interval, and in this case this confidence interval does not contain P. But we see in the long run we expect 90% of the confidence intervals to contain P, 10% not. So if we go back to our example involving the death penalty, we would say we are 90% confident that the true population proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 0.61 and 0.65. Another way we can state that: we are 90% confident that the true population percentage of registered voters who are in favor of the death penalty for those convicted of murder is between 61% and 65%. Thanks for watching.